Hello, and welcome to today's webinar. My name is Adam Golov, Marketing Communications Manager at Data Conversion Laboratory, and I'll be your moderator today. Before we get started, I wanted to let you know we will allow time at the end of the webinar for questions and answers. So please write your questions in the chat area as they come to mind. If we don't have time to answer them all, we will make them available on our website. Next slide, please. For those of you who are not familiar with DCL, we convert and organize content to create electronic documents, populate databases, publish on the web, and basically get it ready for tomorrow's technology. Next slide, please. DCL services help you refine your document conversion strategy, identify document redundancy, extract metadata, and transform legacy and future documents for real needs, today and in the future. Next slide, please. We serve a broad client base. Next slide, please. Spanning all industries. Today we are thrilled to introduce Nave Greenberg, Director of the U.S. Defense Development here at DCL. Nave is a PMI certified project management professional with expertise in large-scale complex conversions utilizing numerous DTD and standards. He specializes in conversions for DCL's defense and tech doc business units and has been instrumental in developing DCL's DITA 2361, 451, S1000D, and 38784 conversion software suites, as well as working with clients to develop detailed project business rules. Nave is a member of the United States S1000D Management and Implementation Group, LAN Working Group, and participates in other discussion subgroups. He has been with DCL for over 10 years and holds a BE in Mechanical Engineering from Stony Brook University. Without further ado, welcome Nave.
Thank you, Adam. Hi, everyone. Hope everybody's doing well. So let's start by trying to find out what makes S1000D conversion difficult. I'm specifically talking about S1000D here, but most of what I'm covering here in this webinar applies to any legacy conversion. So S1000D is a conceptual departure from linear information. People are usually used to seeing chapters, sections, paragraphs, and subparagraphs. It's basically a visual breakdown of the data. For some people, it's difficult to get used to. In S1000D, you try to take a structured book or publication and break it into a collection of data modules. These data modules, not only they need to fulfill the standard requirements, they also need to be capable to stand alone as a unit and possibly be reused in other publications. In S1000D, you also deal with data module codes, illustration control numbers, and business rules. And so because of that, a file name actually has a meaning because you assign a data module code to it. You're also dealing with business rules, and business rules are a set of rules that everyone must follow. But in S1000D, you have layers of business rule. So when you finally get down to the project-specific rules, if you're not careful and very specific, it can cause a lot of issues. So why using data module is so important? Data modules are chunks of information that can be reassembled in multiple ways, repurposed in multiple outputs, and reused across multiple products. This is a very important and powerful thing to have, but getting to that point is sometimes challenging. Now, legacy data was not written as a collection of data modules, and in many cases with no reusability, XML, or items in mind. So a lot of planning and analysis is needed. So in this slide, you can see on the left, there are a few examples of what could be source data. Source data can come in many formats. Legacy data will have a totally different look and feel than S1000D. Even if it was written as a defined standard like ATA or 3784, it probably did not have modular information in mind. And it's difficult to map your data to data modules. Other formats may be a better start, but it's still not the same as S1000D. even if you deal with a standard that already had modular information in mind, like 40,051, 3001, or 87,929, or even DETA, you still need some manipulation before going to S1000D. And even if the source comes in as an earlier version of S1000D, it may be easier to get to the latest version of S1000D as other standards, but if you want to use applicability or process DM, it will require you additional work. But the beauty of S1000D is that once you convert the legacy data, the data module can be hosted in a common source database, and you can use the publication module to construct any kind of publication you may need or want to create. So this looks great on paper, but in real life, getting there is not that simple. So when converting to S1000D, you are dealing with your usual conversion issues. In any type of conversion, one of the first questions that comes up is, how do you assure that text is not dropped during conversion? And we will cover all these issues later on. Another issues are tables. You know, how they look and how they're converted, table spanning, column spec, and all that stuff. In some standards, you can use MathML to tag equations. In S1000D, it doesn't really support MathML, so you need to determine what to do with those equations or special look and format that looks like equations. You could convert them to an image and actually to a vector image if you have the budget to do so. You will also need to address other typical conversion like special characters or symbols. But when converting to S1000D, you have the additional complexities that are specific to S1000D. And I mentioned before data modules and applicability. It's easy to determine what is a chapter or section, but it's not always easy to determine what's a data module. It's even more difficult to determine what type of data module you're dealing with, or assigning a data module code to it. Now, to add to the complexity, you're also dealing with determining what data can be reused. And of course, applicability. Applicability is a powerful thing to have, but it does require analysis and planning, and therefore a lot of time to implement it. In any conversion, but especially in S1000D, you always have to factor in the biggest issue, which is the human factor. Going to S1000D requires you to think differently. And change is always difficult to get used to, and people that are reluctant to change will always find reason why not to go to S1000D. But you need to find a way to have all the stakeholders play nice with each other and agree on all the conversion rules. So how do we move forward and make sure that everybody is on the same page? So the answer is very easy. You need to do a lot of planning and analysis, but implementing that has always been a challenge in any conversion to S1000D. Planning is crucial for the success of a project. Lack of proper planning and analysis is probably the major reason why conversions fail. You can mitigate the risk of poor planning by asking the right questions. So, for example, who are the stakeholders? And anyone who's involved in the project is really a stakeholder. So, for example, you can have the management, and you need to get their buy-in or maybe a budget or approvals. It could be the graphic teams, and you obviously depend on them to deliver graphics that are according to the standards. It could be the XML experts or the subject matter experts, and they need to know what to look for. One of the things that I'm going to discuss later on is that you will really need them only for subject matter expertise worthy tasks. So, because any other task can be accomplished by a cheaper labor. Another crucial stakeholder is the final client. He, she, or they should be involved in the process. You don't want to find out that they don't like the product only after you deliver it. Now, knowing the estimated volume and deadline will allow you to plan accordingly and develop a reasonable schedule and plan. Your process will obviously be different if you need to convert 100 pages or 100,000 pages. So moving on to source data, you will see that not all source data are created equal. If the source data is paper or an image, you will need to take into account scanning, OCR, and cleanup. And this means more time and money. But it will actually let you to manipulate, restructure, and clean the source data in a more familiar environment like Microsoft Word. Source data in electronic format will save you time because you don't need to OCR and do major cleanup. And in some cases, you may even be able to use some of the paragraph styles that are used in the source data to map it to S1000D. But styles are not always used consistently in your source data. So you can't just blindly map them to S1000D. Another question is what version of S1000D you're going to go to. If you want applicability, process DM, and other features, you will need to go to a newer version. It's also very important to know what content management system or rendering tools will be used. In theory, if you tag to S1000D, you should get the same output regardless of what tools are being used. But that is not always the case. Some attributes or elements are needed in one tool but are not needed in another tool. Or maybe they're optional or rendered differently. So you need, it helps a lot if you have the content management system and the rendering tool known at the beginning of the process. Obviously, knowing your budget is very important. Usually, the more you have, the better off you are. And another important item to do, which people don't always do, is try to join as many S1000D discussion groups you can. Because other members could have the same or similar challenges that you have, and they may be able to answer some of your questions. And try to get your hand on as much source data as possible when you start the analysis. That way you can look for inconsistency and variation, and the more you have, the more accurate your analysis will be. And that applies also to, obviously, the business rules and playing around with the schemas. You will need all of that during the analysis phase, which we're going to cover later on. And start thinking about building your team. Someone in your team should be comfortable enough with S1000D to make logical decisions when you decide what to do with the project-specific business rules. So the easiest way to get an answer for the initial question is by possibly creating a questionnaire. Now, you can see you don't need all the questions, but the more you know, the better off you will be. This is really an old example of a questionnaire. It can be as detailed as you want it to be, but try to cover the main concepts of S1000D, and try to get involved, all the stakeholders involved in order to get all the answers. So questions like, for example, what type of manuals do you have, or what is your source format, will let you know what you are starting with and what to expect. Like, do you need to add scanning and proofreading to your process? Will this affect your schedule? You need to take that into account when creating a schedule that really makes sense. Also, if you have troubleshooting flowcharts that you need to convert to XML, you may need a subject matter expert. You may also need to involve the client to understand the data. If you know that you're only dealing with procedural and descriptive data module, your process can be a lot simpler. So the answer to these questions give you something solid to work with and start the conversion process aware of possible obstacles that otherwise you won't know and find out later down the road when it's more expensive and more time-consuming to implement them. Actually, I want to cover the last question, question 21 over there, which means what level of granularity will you be expecting? Now, the way it's phrased is a bit dangerous. I don't know if it should be a question. It should really be a discussion with all the stakeholders, because everybody wants all the bells and whistles. And S1000D, offers you a lot. And if you deal with legacy data that is missing a lot of items that will be used to get to that point, you will need to decide what's possible and what's not possible. Fitting legacy data to S1000D can be the same as fitting a square peg into a round hole. But if you set expectation with all the stakeholders, this becomes a possible task. So go over that before you start full conversion. So you need to make sure that you plan ahead of time and also have a solid conversion process. So this slide shows a typical conversion process, and it's obviously not set in stone, but it's a very good model to follow. So just quickly going through the 5 phases, you will see in phase 1, it's really where you should analyze the client requirement. You can assign a project manager there, you can start building the conversion team, and in phase 2, you can create the conversion specification and a tagged sample. And I will talk more about the need for a conversion specification and what it should consist on in later slides, but it's basically the tagging rules of the conversion process. And you should walk through the conversion specification with the client or major stakeholders to make sure that everybody is on the same page. And based on that conversion specification, which really ties to project-specific business rules, you should produce a tagged sample to show everybody how the rules will be implemented. And it will be great if you can actually produce a sample item or upload a converted sample to a content management system as a test. Obviously, if you have that luxury, and if you see the product working at a smaller scale, it will make your life a lot easier when you try to implement a larger scale. So in phase 3 is usually when software is developed or customized or tweaked, and in phase 4 is where proof of production should occur. You should run a larger sample that is representative of your entire data set through the process. When everybody is happy with the converted data, you should have a sign-off and move forward. And in phase 5 is when the project enters the production phase. So here is a more detailed breakdown of a typical process. We're really only going to cover the first few steps. It's the ones that are highlighted in green because they're really the ones that cover your planning and preparation phase, which we're going to focus on in this webinar. So the first step I'm going to cover is inventory and assessment. So in a typical project, source data is usually submitted in batches, or even if it's not the case and you get all the data up front, there's still the need to log the data into some sort of a production control system that keeps track of each unit. A unit can be a manual, set of manuals, or anything else that will make tracking the data possible. You can record some metadata on each unit that can help you create a useful report. Metadata can be a batch number, number of pages per batch, date the unit was received, and as you convert the units, you can track other metadata such as date when each step of the production process occurred. And the importance with this data is that it can be used to project delivery schedule. It can confirm that the processes are working properly and track each unit to see in what step in the production process that unit is in. So, but next is that you need to decide what data should be converted or in what order. So try to categorize your data, and some of the categories that can be used are active documents that are in good shape, active documents that need a lot of work. You can also categorize it as documents that are somewhat inactive that may be retired. And the last category can be archival materials, which basically materials you don't need or that are not going to be updated, but you still want around. And according to that, you should prioritize your data. So documents that are mostly used or documents that are customer favorite should be higher on the priority list. And also documents with the longest product life are candidate to be high on the priority list. And once you create your priority list, start with the most recent and higher priority document and go back as much as you can or as much as the budget allows you to, and start converting also the lower priority documents. And at this point, you need to determine the conversion process. So see if there are any documents that can be converted as is. It could be documents that are already in modular format or the ones that are in really good shape. You will also need to do some preliminary work on some files, maybe cleanup or restructuring of the data or fishing out the metadata before you begin the conversion. So some data may even require you to rewrite in order to fit S1000D. So especially in cases where something is required by the standard and is missing in your legacy data, items like preliminary requirement or introductory data that can be used in numerous data modules, those are the ones that might be missing, or you may need to duplicate, or you may need to rewrite in order to fit in every data module. And you can also determine what some data is now worth converting. You may just want to keep the data in its original format. And if you still want to have access to them from your converted data, you can either create a descriptive data module and link to them as an external file. So they're still part of the database, but they're not converted to S1000D. So the next step that we're going to cover is content reuse. So the idea with content reuse is that every time something is used, you try to pull it out and convert it only once. So you can assume that front matter will be similar in many documents, but how similar you can't just tell by looking at it. You also cannot tell where else in your documentation you will find duplicated data just by looking at all your documentation. But reuse is very, very important. And some of the benefits for reuse is obviously it increases consistency, it reduces development time, it lowers maintenance cost, and it's rapid configuration or usage in other publications. You can use it across many publications. By knowing your reuse potential, you can sort of divide and conquer, because now you can go through your content reuse report, find set of documents that are in good shape, and make that your initial base documents. And then you can take other documents against those so-called base set documents and go back and adjust them according to your base documents. And by the time you're ready for full conversion, you will actually have sections that are really identical and can be pulled out. So this is just a snapshot of a report that is really created by an automated tool. And now this is just a pie chart that can tell you really a lot. It basically tells you that almost 25% of this data set is duplicated. So can you imagine, this is an immediate saving, a potential immediate saving of 25%, and that's a lot. Now obviously this is not necessarily the case in every data set, but every duplicated text will be converted only once and probably used many times. And you probably need further analysis to make sure where those documents are, where this duplicated text is located. But if I know there's a chance of cutting cost by 10 or 20%, I will look into it further. And I'm going to show you in the next slide how can you take that a step further and look at your documentation and see exactly what duplication you may have. So you can see over here you have some base paragraphs and exact matches and close matches. So you could actually use some paragraphs that are similar to your base paragraphs and maybe reuse them with the addition of applicability or revising or rewriting that specific paragraph if it doesn't change the meaning of the paragraph. So in the first example, you can see that there's an exact match of the base paragraphs in 3 other manuals. You can actually review that section and see if you can create one data module or one chunk or one paragraph and use it as many times as it's duplicated. And in the second example, there isn't an exact match, but it's close enough to raise a flag and indicate the possibility of reuse. And if you can see, the first paragraph discusses model number FD-5200, and the second paragraph discusses a different model number, FH5200. So in this case, you still can reuse the paragraph, but use applicability to distinguish between the 2 models. So another difference actually here is that in the first paragraph, you have, it states that seal weld should be visually inspected. And in the other paragraph, it says seal weld shall be inspected. So the word visually is missing. Now, this tells you 2 things. Number one, you could say that possibly the word visually is missing because of a typo, and you should insert it. Or maybe the inspection is different when dealing with different model number. So you actually make your data a lot more accurate, and at the same time, if it is a typo, you can reuse it. So here you see a report that tries to group identical paragraph in sequence. So if you see that there is an identical paragraph that appears somewhere else, you look at the paragraphs that are before and after it and see if they're identical. And this can help you determine if if a set of document or procedural steps or just set of paragraphs can be used, and even better if an entire data module can be reused. So the next steps are document analysis and conversion specification. So during these 2 steps, we will cover items like determining the ease and accuracy of content extraction. So if you need to scan and OCR your data, you need a solid proofreading process, and I will show you in the next slide an example. You need to identify your metadata. You need to identify the type of information in the documents and the appropriate level of tagging. You also need to identify a process for various material. The process is obviously going to be different if you're dealing with source data that is paper, Word, XML, FrameMaker. You need to adjust according to the source data. Next is detailed analysis of document type. So obviously if you deal with IPB or troubleshooting or procedural or operational, all will be handled a little bit different. And obviously review enough documents to understand the potential variation. And this is crucial during analysis. So the more variation that you see up front, the more robust and your rules will cover more scenarios. Develop the tagging instruction and prepare specification so the documents can be processed consistently, and I'm going to cover that later. And the main point is normalize your data. So the software handles consistent data. So here is just an example of something that may be considered as trivial, but it's very crucial. So extracting text is a problem in any type of conversion. And the OCR tools that are out there are very sophisticated and very high accuracy, but when you're dealing with data that is not structured to paragraph or has special characters, that's very challenging for OCR tools out there. So you could obviously have somebody go character by characters and go and check every document, but that's a very, very time-consuming task. And if you're dealing with a lot of data, you need to kind of include workarounds and do solutions that will speed up the process. And one solution can be using unique styles or maybe change characters such as 1, 0, 5, all the characters that are known to be an issue during OCR, make them unique, so it's going to be easy to distinguish between a 1 and L, an O and a 0, a B and an 8, all those kind of characters that otherwise you have to fish them out and look at them one by one. Another thing is to have a proofreading process that is accurate. So I mean, if you see in the bottom, you can actually align the image that you're scanning on top and then the output on the bottom, or the other way around. And then what you do, you actually can quickly go character by character if you have the luxury when you get to that point and see that it was OCR'd properly. So there's obviously many ways to make sure that data is extracted properly, and again, that's a different subject, but you can also do automation, you can do a diff process, you can do a lot of ways, but that process is your beginning point. So if you extract your data and your data is incomplete or in bad shape, you're starting with bad quality. To get to a good quality is quite a walk. So, for the DMRL, you really need to find a way to extract all your titles into a spreadsheet. One way to do it is by using the document table of content, because if you start with source data that is not electronic, you really go through your documentation and extract all the titles. So one way is to take the table of content, but it's not always a complete list. Some table of content in your legacy data might cover only the first 2 or 3 levels of hierarchy. And many documents, especially old legacy data, could have a lot more levels of hierarchy, which you may want to separate into different data modules. So this is why sometimes it's better maybe to prepare your data before creating your skeleton DMRL, which basically just extracting the titles, because I'm not talking about assigning a data module code, and because that's really a totally separate webinar and requires sometimes requires subject matter expertise on data module requirement list and on your data itself. So, and again, how to prepare your data, I'm going to talk on the other slide, but in a DMRL, you can actually also assign other important information. So for example, information in the identification and status section, or maybe if you want to change the value of your tech name, you can also add any kind of special information. So for example, if you want to state that's a chunk of data that will be used as an introductory paragraph should be repeated in the following 20 data module, you can actually place a comment over here and you can incorporate it into your process. And something that goes side by side with the DMRL is the conversion specification. And a conversion specification is really a guide and to some extent the project-specific business rules, or an extension to the project-specific business rule. And some of the items that are covered that could be covered in the conversion specifications are the elements that are found in the documents, examples of where these elements are found within these documents, possibly a rule as to how these elements will be identified, a sample of the way they'll be tagged, and any open items that are connected with these elements. And you'll be surprised how effective this document can be. Now, besides having all the stakeholders on the same page, you have all the major rules documented. And this can be a live document, so when you find new issues, you can add them to these documents. And the more you invest on the conversion specification, and again I'm saying also project-specific business rules, the less issues you will have down the line. And we know that finding issues once you start conversions will take a lot more to fix and to implement, and also what do you do with data that was already converted. So really a crucial rule is to spend as much time up front, and that will save you a lot of time later on. But you do need to make sure that at some point you stop and set your default scenarios, because if you stop each time you find something, you will never complete this analysis. So you need to find that middle ground between setting the right amount of rules and defaults before going into full production. So your data comes in different shapes and forms. You can try to convert the data as is, but your converted XML file will probably need a lot of cleanup. Right? So your goal with large legacy conversion is to try and normalize your data, and there are really three main reasons for doing that. First, it will produce a more consistent and accurate results, and it will also allow software to deal with what it's really best for, and that's running your data through predefined rules. And it also you can have cheaper labor normalizing your data and have your experts deal with real complicated issues. So this is an example of basically a document that is used by people who normalize the data when preparing the file for conversion. So you can see that there are some rules that for someone looking at the data is very easy to implement, but for software it might not be, because it's changing so much throughout the documentation. Like title hierarchy sounds easy to determine, but it can easily change from document to document. And defining all the rules for conversion software might be very, very difficult and time-consuming task. And by looking at the data, somebody who doesn't even understand what the data is about, he can determine what's a title by visually looking at the data. And you can always develop QC software for this step and the pre-editing step that we call it, that are fairly simple, that could help normalizing your data. And we'll cover that as well. So just a simple example, when it comes to tables, and even though tables are fairly simple, they can cause a lot of problems with converting your data. So here you have a table that is spanning over a few pages. In Microsoft Word, you can actually mark the table header as a repeat header row. And you can see, like over here, the first row is marked as a table header, but all the sections that are continuing in the next pages, they don't need that, because they're always going to inherit that table header. So you can take the risk and have the software always convert the first row in the table to a table header, but that is not always the case. In some cases, table headers are more than one row, and in some cases, there's no table header. And in Microsoft Word, you can have really anyone just look at the data and select the table header, whether it's one column, two column, one row, spanning, not spanning. Just visually looking at it, you can detect the table header and mark it in Microsoft Word, and the software will handle that. And you can add automation in this process by always, to save time. You can actually have automation that will go to the first table, to any table, and always mark the first table as a table header, and then just somebody has to go through the document and fix those one off and not. But you're dealing with Microsoft Word, and you don't need somebody who is highly experienced in XML to do that. So you can have cheaper labor working on it than having a subject matter expertise go through and decide which one is which. And just one thing, an example over here with the pre-edit tag, you see over here the TS and ET, and basically what it can do is tell the software where to start to combine the table and where to end it. And you can add a lot of QC steps over here to make sure that you don't have, the table doesn't jump from 6 columns to 7 columns. You can make sure that suddenly you don't have any text that is outside the table in between the sections, so you may not just have a note floating around. So you can develop very, very simple QC tests to make sure that it was done properly. So here you have a table that is very complicated to type for a few reasons. First, obviously, it spans over a few pages, and you also have the curly brackets over here that indicates a jumper, and the number of columns change from page to page. And you know, it's still, but it's still one table when you convert to XML. So you can have one table with multiple T groups, but when rendering the table, it's not really going to look very nice. So I hope, yeah, you can see. So one option is to convert these tables to images, but that's not obviously the ideal solution. Another option is to replace the curly brackets with merged cells. And obviously, again, the TS and ET created over here indicates the software where the table begins and where it ends. And obviously, you can add the QC tests to make sure that it's done properly. And you also only need to worry about the first part of the table to look nice, because other sections will inherit some of the attributes over here. So, for example, you know, obviously the table header you don't need to duplicate. You know, column width, you don't need to make sure that it's always, you know, aligning and everything. It saves you a lot of time when you don't need to, you know, when you don't have to start aligning all your data. As long as the first section has the proper look and feel, the rest will inherit that. And just, you know, because the table columns change from page to page, to make it easier for the software to combine everything, you have to make every section, let's say around 10 columns, make each section a 10-column table. And you can actually tell the software always delete the last one, or put like a marker over there so the software will know to remove it when combining it. Now, it's, you know, telling a software to do a step, but it's very easy for the software to do hundreds of tasks, because it's just machine time and it's very easy to implement. And it's better for software to do it than for a human being. So in this example, you see a few things. First, the metadata, or in S1000D, the preliminary requirements over here, it can be flagged in the DMRL when all the title the title styles are extracted to a spreadsheet, like para0 and sub-PT1 and all that stuff. And when they're extracted to the DMRL, you can tell it what it is, or you can detect them by automation. You can also have the steps hierarchy done here, for example, a step 1 and step 2, and that is easy to determine by visually looking at it. You don't need to know the data in order to determine what's a step 1 and step 2. You may need to use a unique style in the procedural data module to distinguish between a procedural step and a sequential list, but you know, if software cannot tell you whether something is a step or a list simply by running on the document. And somebody just looking at the data, it's very easy for them to determine what's a list and what's a step. So now when converting to XML, and especially to S1000D, obviously the concept of pages goes away. So why in all the examples that you saw, you still see that they're being maintained? Well, in old legacy data, there were reference to pages, and that actually gives you a bookmark that the software will know where to link to. So let's say over here it says see page 2-3. Now, in the paper world, when you read it, okay, you went to page 2-3, and you knew that it was repair or replacement. Software doesn't know what's a page, so when you run software and you keep the page mark as bookmarks, you can develop a rule that says, okay, go to this location and go to the main element that you see in that page, and you can predetermine what's that element. And in this case, it's repair replace, so you link to the right place. Now, that obviously has to be determined before you start conversion. it basically leads us to the question, what if during mapping, removal and repair or replace are not section, but actually brand new data modules. So, now, if this issue is raised during analysis phase, all you have to do is just revise the styling, and as shown in this task, like over here, it's actually an example of where they're not data modules, they're actually steps, and then they become your first hierarchy step level, procedural steps, and then the other ones are second level and third level. But as we said before, another option is when they actually become data modules, and in the DMRL for this case, you actually set it in your data in your DMRL, and you actually define it as either, the first example shows that they become brand new data module, and in the second example, it shows actually as a step. And the way the software runs, saying, okay, I open a data module when I get to repair replace, the power 0t, and they become steps. So this is it. And if you have any questions, I hope you enjoyed the webinar.
Thank you, Nave. A very informative webinar indeed. The first question that has come in is, where in the process do you need to involve the client?
Okay, so I think it's important to involve the client throughout the entire process, but the type of involvement is obviously different in each step. So I think it was, let me just go back, it's going to be easier for me if I see the process. Okay, so for example, in each step, the involvement is going to be different. I mean, at the beginning, obviously, the client knows the data better than anybody else. So when you ask questions such as, what am I dealing with? What type of documents I have? Do you know any reuse? Do you know if there's going to be any reusability? Basically, when you're scoping the project, the client has to be involved. 100% of the time, it has to be involved. Now, when you get to the stages after defining the scope, and you get into the so-called production phase, or the implementation of the rules, the conversion specification, your DMRL, they need to be involved for, really the main reason is that they know what they're getting. And the more they involve throughout the process, the happier they are because they know what they're getting, but also you get their input and not your interpretation of what they want. So even when you get into the full production, we actually, obviously if the client wants to, we ask them to review data that comes out, not to wait until everything is converted. But we say, okay, there's going to be steps throughout the production process where you take a representative sample and you review it and see if it's really what you want. Because otherwise, you find it at the end and you're facing two issues. Number one, you're not going to argue who's right or wrong, but in reality, he's not happy, or she is not happy, or they're not happy. It's always better to get it resolved at the beginning of the process than at the end of the process.
Thank you, Nave. The second question has come in is, what if you don't have a CSDB? How does it affect the conversion process?
Well, I don't think it stops you from doing a conversion, but you don't really get to see the final product. And you do validate the files against the schema and the breaks, and it doesn't necessarily mean it will look the way you want it to look when you do finally get a common source database or a rendering tool. Having just the XML doesn't really do the job, and you need the environment that will allow you to sustain the data and render it and maybe exchange data, because even though common source databases and rendering tool, if you tag to S1000D, should display the same thing, in reality they don't. And if you convert using one rendering tool in mind, you can test it, you can see that it looks good, and what happens if you don't, it might work fine in one rendering tool, but it will be missing some required attributes that are not required by the schema or by the so-called project-specific rules that you develop, but you have that chance that maybe it's not going to render perfectly. So, it's kind of dangerous not having it, but it's not a total showstopper.
Thank you, Nave. The last question that has come in is, some legacy data is missing a lot of data that is required by S1000D. How do you decide when it's not worth converting your data?
Well, obviously budget is a big concern, but we discussed that during analysis, and again, this is a great example why analysis is so crucial. So before you even think about doing the conversion, the first thing that you do is okay, see what you need to convert, categorize your data, review the data, look how, what you're dealing with, and after doing, as detailed analysis as possible, you can categorize the data. If everything falls under, documents that need a lot of rewrite, then you may need to prepare the data before conversion. I mean, you can, if you don't have the expertise, you can write the documentation in Word and have it converted, but you really need to categorize and prioritize your data before you start going full funnel into conversion. But it's really, you find it out during analysis, and that's why you do the analysis, to find that at the beginning of the process, then later of the process. Because some conversion may say, okay, we'll convert it, and anything that is missing, we'll insert empty elements, and when the converted data is uploaded to the environment that will be used to sustain and maintain the data, somebody's going to come in and insert the missing data. And that can take years. As crazy as it may sound, it can take years to insert all the missing data for two reasons. Because when you're dealing with XML, you have to have subject matter expert go in and say, okay, where's my part number? Where's my man hour? What's my preliminary requirements? What's the personal requirement? A workaround on that can be, okay, bring the data before conversion into a familiar environment. We can have multiple people work on it and pull this specific information and prepare it before the conversion. And that will save you time and money because you have a lot more people that can work on Word or Framework or whatever the tool is than specifically in XML. And you may not need to use people with the same high expertise that you will need when already the data is converted to XML. I hope that's answered the question.
Well, thank you, Nave, and thank you, everyone, for attending. This concludes today's broadcast. You'll be able to access the recorded version of the webinar in the webinar archive section of our website located at www.dclab.com. Our next webinar will be Tuesday, December 8th at 1 p.m. Eastern Time, titled Minimalism Revisited. Let's Stop Developing Content That No One Wants, presented by Joanne T. Hackles, President of Context Services and Director of the Center for Information Development Management. Thank you, everyone, for attending, and have a great day.